Welcome to today's coffee break. My name is Joop, and today we have a very important topic, and that's safety. Everybody is concerned about safety, and I want to talk a little bit today about how we can help you to make your facility safer with some tools that we have, and maybe with some methods that we have, and maybe make safety a part of your culture. Let's take a look how that works. So safety, let's talk about safety. Safety, of course, is very important. Nobody wants to get any accidents. You know, it's harmful for the persons. It's harmful for the business and for the environment. So, you know, we need to make sure that we respect safety and we do anything we can to make sure that we operate, we build in a safe way. Now, the one thing to understand is that, you know, you cannot put a price on safety, and we have seen several examples in the past years actually where we had some incidents, and I think I don't have to elaborate, you know, that there were some very expensive things going on with that. So you can hardly put a price on that, and certainly when lives are involved, you know, what can you say? So it is extremely important. On the other hand, there is always a risk. I always say when you get up in the morning, you know, and you go to work, you run a risk. You run a risk driving your car on the highway, but you know when you build a plant, when you operate a plant, there is a risk. There is no two way about it. But the key is now, of course, to understand these risks and then, you know, make the right call to say, okay, this is a risk I can accept. You know, if for instance you have a system and you have a risk, it overflows, but the overflow is water. Well, okay, a little bit of water on the street, you know, not a big deal, it's inconvenient. On the other side, you know, if you have a risk like gas escaping and it may explode, that's a different story, you know, this is a different risk, and then you have to just mitigate, you have to do something about it, you know. And we had more and more, of course, of safety issues over the years, and I think on one hand it is not so that we did a worse job than years ago, but the fact is that there are so many more plants. Of course, there are rebuilding, you know, more and more chemical plants, refinery, whatever. Of course, the demand in the market has grown so much over the years with growing economies like in China and India. So, I mean, this is the sheer fact that there are a lot more of these facilities. So, and you know, when you have more of those, you're in a higher risk. And there are very complex processes in these plants. That also could be a risk. You know, we have a lot of gas plants these days with LNG. We put this in big ships, and of course that you run a risk. And we didn't have so much that in the past with the gas plants. So we also, you know, you have to look at you know, the reduction of resources that we have. I have a shortage of resources of skilled operators. You know, operators that are very skilled. They retire. And what do you do? So when you get the young guys on board, of course they do a good job, but of course less experience could be you know, another risk that you're introducing. Now everybody has to run a business. We have to run a business here. You have to run a business at your company. So you also have to weigh against the, like I said earlier, about the type of risk. The water is not a problem, the gas is a problem, but you also have to look at you know, the business aspect. To build a plant that is 100% safe, I don't think anybody can afford that. You know, to eliminate every possible risk, you know, there is no business case you can make that. So it is, you know, weighing off against the risk and the business as well. That's just the way it is. Now I look at the safety in four different areas. Of course, you have the process safety. Most people are familiar with the HACCP studies. It's just a method to understand the risks. You go to all these different scenarios in your process, mostly using a P&ID, and understand what happens if the pump stops, what happens if the valve doesn't open, and you go to this scenario and understand what happens and what the risk is, and then you decide if this risk is you can live with it or you can not live with it. And if you cannot live with it, then you have to find a mitigator to eliminate that risk as good as you can. So that's the HACCP studies. Now the other one, of course, maybe I should put that first actually, is the personnel safety. You don't want anybody to get hurt. So we need to look at how to operate the plant safety. If the handles of valves, the shut-off switches, the escape routes, if that is all designed well, so that if something happens, that personnel is either protected or has a way to just get out safely. Then of course the safety of the facility itself. You need to design your plant for instance, an explosion. Let's say, for example, an offshore platform. Normally when you have a larger offshore platform, you have the living quarters, the hotel basically on one side, and then you got the Christmas tree, the wells on the other side. And of course when an explosion happens, you don't want to blow off the living quarters of the platform. So what you do is you have to do some studies on explosion simulation to see if a fire happens, if an explosion happens, that you design maybe with firewalls, or you design openings in the deck so the pressure can go out to the sea and not to the platform. So that is, make sure that you design your facility, for this accidents, and be safe, and especially like a living quarters, you don't want to have anything happening with that. And last but not least, everybody wants to, of course, to be green, and the environmental situation is also very important. Whatever you do in the plant, whatever you produce in the plant, you want to keep in the plant. Sounds like logical, but there are many examples. Several years ago, I think it was in Eastern Europe, there was an aluminum plant, I think it was, and they got some stuff out of the plant that flooded acres of land with very, very, very toxic fluid. It was mixed with the water. So you don't want to do that. That's what I mean. You need containment to make sure that whatever you produce, whatever you create, is not getting in the air or getting on the ground or getting in the groundwater. So that is also something that you have to design for and have to understand the risk. So if you have a tank farm, you build a wall around it in case that something is leaking, you keep it contained in there. So that's what I mean with environmental safety and leakages. LDAR is also something that falls in that category, that you have leak detection repair. You need to make sure that you inspect your plant and not get these harmful things in the air, or maybe cause explosion because it gets out there in the plant. Now the best medication, there are several medications I will call up on in a few minutes, but the best medication of safety is of course to design for safety. I know it is sometimes a challenge, but I think when you design a plant, when you design a process, you can actually keep in mind that you have basically a fail-safe situation, that if something goes wrong, the plant has been designed, or the system has to be designed to basically, shut down in a safe state without actually doing anything, from the outside. That's the best thing. You have to design for safety, but not always possible and not always cost effective. Remember, we also have to look at the business side. So a good mitigation systems or methods are of course control system. Instrumentation is obviously many times used, to mitigate the risk, with high level, high pressure, or whatever. You can set up alarms and shut down systems. So that is definitely a good mitigator and used a lot of way. And like I said, you can build for safety. You can understand the risk where fire or explosion can happen. Then basically you make sure that you design the structure or the way that explosion pressures and gases can escape in such a way that you don't harm personnel or the rest of the facility. There are systems out there in the market that you can simulate these situations. And also you can do area classification, make sure that you understand where hazardous areas, hazardous situations can exist. So you make sure that your equipment, your panels and so on are designed for it and be safe. And then of course, last but not least, you get location. If you're in the middle of the desert, maybe you have to look at risk a little different than when you build a refinery in the middle of the city. I've been to Los Angeles and I've been on a couple of refineries that where when you step out of the gate of the plant, or across the street are houses. So I mean, obviously there is a little different perspectives on safety and risk than, like I said, than when you're in the middle of the desert. Now, don't misunderstand me, you always have to be safe no matter what. So basically, when you look to safety, there are three modes. You have people that are reactive. An accident happens. Okay, we're going to do something. That's not a good situation. And then of course you get intermediates. People that now and then do something about safety. But of course the best is to have a sustainable operational excellence, that you make safety basically a part of your culture and make that part of the way you do business and the way you design and run the plant. Because in the end, no matter how you look at it, being reactive will have a higher cost, because blowing something up is very costly. And being sustainable and operation excellent will allow you to increase production, because any accident will shut down your plant and shut down production. So make safety a part of your culture, and that's basically my pitch for the coffee break of today. Hope you learned something from that, and maybe put some thoughts in your mind, and when you build or operate the plant. So with that, thank you for your time, and we'll see you at the next coffee break.